Project Management Professional Training Session 13 Part B. Figure 12.4. An example of a cause and effect diagram. Explore the causes for a delay in a website release. Tip: while constructing the cause and effect diagram, you can use the brainstorming method to identify the potential factors of causes and the potential causes for each factor. A cause and effect diagram offers a structured way to think through all possible causes of a problem. You can use these diagrams to carry out a thorough analysis of a problematic situation. This kind of analysis is useful in complex situations when, to discover the real causes, you need to explore all the potential causes and not just the obvious ones. In the manage quality process, cause and effect diagrams can be used to identify the main or root causes of defects, while in the control quality process they can be used to find the potential effects of quality defects and errors. In addition to the 7 quality tools we have discussed, there are some other tools that you can use for quality control. Other quality control tools. 2 other quality control tools are discussed here. Inspection. This is a technique used to examine whether an activity, component, product, service, or result conforms to specific requirements. This can also be used to verify defects and implications of their removal. Inspections can be conducted at various levels of project execution. For example, you can inspect the results of a single activity, or you can inspect the final product of the project, or both. Nevertheless, inspection generally figure 12.4. An example of a cause and effect diagram. Explore the causes for a delay in a website release includes measurements. There are various forms of inspections, such as reviews, peer reviews, audits, and walkthroughs. Testing and product evaluation. This technique is used to find bugs, defects, and errors in the product, and also to verify its conformity to quality requirements and standards. Testing does not have to wait until toward the end of the project. Rather, it should be performed side by side with development. As a product or its component is developed, it can be tested. This approach will be less costly. The kinds of tests depend upon the application area of the product. All this work done by using these tools generates the output items for this process, discussed next. Study checkpoint 12.5. Match every item in the first column of the following table to the items in the second column. Data presentation tool A use. A. Flowcharts 1. To identify the most important area of causes of defects. B. Tally sheets 2. To find the relationship between 2 variables and find potential causes of defects. C. Scatter diagrams 3. To anticipate what quality problems might be and where they might occur. D. Histograms 4. To monitor whether the variance of a specified variable is within the acceptable limits. E. Affinity diagrams 5. To find the frequency of defects. F. Control chart 6. To explore all the potential causes of a problem, not just the obvious ones. G. Cause and effect diagrams. 7. To display the relative importance of different variables, e.g., its causes. Output of quality control. The quality control measurements, verified deliverables, work performance information, and change requests are the main output items of the control quality process. These and other output items are discussed in the following paragraphs. Quality control measurements. These are the results of the control quality activities and are fed back to the manage quality process in the form of a document as specified in the quality management plan. They are also used to make recommendations for corrective and preventive actions or other change requests. Verified deliverables. These are the deliverables whose correctness and conformity with quality requirements and standards have been verified through the control quality process. They are fed into the validate scope process discussed in Chapter 4. The rejected deliverables come back for verification after repair. Work performance information. This document from this process includes information about the following items. List of verified deliverables. Causes of rejections. Status of project requirement fulfillment. Status of quality metrics. Recommendations for corrective actions and process adjustments. Change request. If in the quality control process changes need to occur that affect a component of the project management plan or a project document, you need to generate change requests that must go through the standard process. Of course, you can have meetings regarding topics relevant to quality control, and you will have to make needed modifications to documents such as those listed for modification in the output column of Table 12-4. In a nutshell, the control quality process verifies the deliverables and makes quality control measurements by using inspection, data analysis, data presentation, and other techniques to check if quality requirements are met and quality standards are conformed to. Quality management is closely related to risk management. Let's say you are doing a fine job controlling quality. However, if an unidentified risk suddenly strikes or an already identified risk event has occurred but the planned response is not being implemented in a timely fashion, quality is one of the possible victims. So, controlling risks is as important as controlling quality. Study checkpoint 12.6. Match every item in the first column of the following table to the items in the second column. An item in the first column may match with more than one item in the second column and vice versa. Item appears in A. Quality metrics. B. Quality control measurements. C. Quality report. D. Test and evaluation documents. E. Approved change requests. F. Work performance data. G. Deliverables. H. Verified deliverables. I. Work performance information. J. Change requests. 1. Input to plan quality management. 2. Input to plan quality. 3. Input to control quality. 4. Output of plan quality management. 5. Output of manage quality. 6. Output of control quality. 7. Input to monitor and control project work. 8. Output of perform integrated change control. 9. Output of direct and manage project work. 10. Monitor and control project work. Monitoring risks. Risks are monitored by using the monitor risks process, which includes the following: tracking the status of identified risks, monitoring residual risks, risks that remain after risk responses have been implemented, identifying new risks and making sure that they are analyzed and responded to if needed. Evaluating the effectiveness of risk processes. However, the risk situation can change with time. Therefore, monitoring and controlling risks also includes monitoring risk dynamics, which involves the following: ensuring that the project execution is conforming to the risk management policies and procedures, determining whether the project assumptions are still valid. If an assumption becomes invalid, it may eliminate a risk or may give rise to a new risk. Determining whether the current analysis has changed the risk assessment. A change in the risk assessment may require changes in other aspects of the project, such as cost, schedule, and contingency reserves. Table 12.6 presents the monitor risks process in terms of input, tools and techniques, and output. Table 12.6. The monitor risks process, input, tools and techniques, and output. Input tools and techniques output. 1. Project management plan. Risk management plan. 2. Project documents. Risk register. Risk report. Issues log. Lesson learned register. 3. Work performance data. 4. Work performance report. 1. Data analysis. Technical. Performance. Analysis. Reserve analysis. 2. Audit. 3. Meetings. 1. Work performance information. 2. Change requests. 3. Project management plan update. Any component. 4. Project document updates. Risk register. Risk report. Assumptions log. Issues log. Lesson learned register. 5. Organizational project assets. Updates. That said, the monitor risks process may be explained in the following steps, or tasks in terms of the items from Table 12.6. 1. Get how to and other information about risks. Information about how often, and when risks should be reviewed can be found in the Risk Management Plan, which also contains information on risk management, roles and the responsibilities assigned to each role to monitor risks. PMP In-Depth 465. 2. Get information about risks and planned risk responses. From the risk report, you can obtain up-to-date information on the overall project risk and planned responses to it. All the information on the individual risks needed for this process can be obtained from the risk Register. 3. Get project risk results. You can get the risk-related results from the project execution from the work performance data and output of the direct and manage project work process, and from the work performance report and output of the monitor and control project work process. The work performance data basically provides the project status, including the risk status, e.g., risks to which the responses have been implemented, those currently active, those already closed out, and those newly occurred. The work performance report contains information about work performance measurements. The data and information from both of these documents are analyzed to assess the effectiveness of risk management, as shown next. 4. Generate work performance information, an output item. As already mentioned, the work performance report contains information about work performance measurements, which can be analyzed to generate work performance information, which includes how much the risk results vary from the plan, as well as earned values and forecasts in terms of risks. In a nutshell, the work performance information tells how effective the risk response and implementation processes are. You can also use the relevant data from the work performance data in preparation of work performance information. 6. Reserve analysis. Recall that the contingency reserve is the amount of funds or time in the schedule, in addition to the planned budget, that is reserved to keep the impact of risks to an acceptable level when the project is executing. The risks occurring during project execution can have positive or negative effects on the contingency reserve. You perform reserve analysis at a given time to compare the remaining reserve amount to the remaining risk to determine whether the remaining reserve amount is adequate to handle the risk. 7. Audit. You will be responsible for conducting risk audits with the frequency suggested in the risk management plan. These audits are usually done to assess the effectiveness of the risk management processes. They may be conducted as a part of project review meetings or risk review meetings, or just as separate audit meetings. As is true for any audit or meeting, the objective should be clearly defined before it starts. 8. Risk reviews meetings. You can put risk reviews as an agenda item at project status meetings or hold separate risk review meetings. These regular reviews can include activities such as assessing current risk, closing outdated risks, identifying new risks or secondary risks that occurred as a result of applying the responses, recoding lessons learned, and discussing other risk-related issues. Having these risk reviews on a regular basis helps make risk management smoother and more effective. 9. Modify documents. The documents that may change in this process are listed in the output column of Table 12.6. For example, as a result of risk monitoring, the risk register and risk report will be updated with new information and the status of individual risks and overall project risk, respectively. Also, the risk report can include the results of the risk audit on the current effectiveness of the risk management processes. As a result of the risk monitoring and controlling processes, some organizational process assets might need to be updated, such as savings templates for the project management plan, risk register, risk report, risk breakdown structure, RBS, and the lessons learned knowledge database. 10. Generate needed change requests while monitoring risks. Some changes may be needed, e.g., preventive or corrective action, more funds, or a schedule change. As always, for proposed changes to any component of the project plan, such as schedule baseline or cost baseline, change requests must be generated and processed through the Perform Integrated Change Control process. There can be risks related to procurements, which also need to be monitored. Also, in general, like any other part of the project, you need to monitor and control procurements, which you do by using the Control Procurements process. Study Checkpoint 12.7. Q1. Why might you end up updating the assumptions log and lessons learned register during the monitor risks process? Q2. The work performance information, an output item of the risk control process, is an input to which process? Q3. Which other processes generate work performance information? Control procurements. Controlling procurements is the process of ensuring that the performance of buyers and sellers meets agreed upon procurement requirements, and that procurement is properly closed. It includes the following: 1. Manage procurement-specific relationships. 2. Monitor the performance of the procurement part of the project. 3. Manage procurement-related changes. 4. Close procurement contracts. Administering procurements has a two-pronged goal: the seller performance meets the procurement requirements, and the buyer meets its agreed-upon contractual obligations. Depending on the size and complexity of the project and the structure of the performing organization, procurement administration may be handled by a group outside of the project organization. But you will still need to integrate the procurement function with the project and act as a communicator and coordinator to ensure that this function is performed smoothly and without adversely affecting the other aspects of the project. This is accomplished by monitoring and controlling the interface of the procurement processes with non-procurement processes, such as those from quality, risk, and integration management. Most of the input and output items in Table 12.7 reflect that interface. Core of controlling procurements. As discussed earlier, procuring an item is equivalent to procuring or outsourcing a piece of your project with its share of the scope, requirements, cost baseline, project schedule, stakeholders, and risks. However, this procured piece is still connected to the whole project and can affect and impact it. In this context, the core of controlling procurement is to manage the interface of the procurement processes with the other processes of the project, as alluded to earlier. In this section, we will illustrate how you do that. The input and output items in Table 12.7 represent the interface you need to manage. From this and other chapters, you are familiar with all these items and their roles. In the following, we will explain in a compact manner how to manage this interface. Manage information about the procurement. For this process, information about the procurement buyers and sellers comes to and is managed through two kinds of documents. 1. Documents from procurement processes, e.g., agreements, procurement documentation, and the procurement management plan, and 2. Documents from non-procurement processes, such as the following. The milestone list holds the dates on which sellers must deliver specific results. Procurement-related assumptions go into the assumptions log. The risk from the seller's side goes into and is managed by using the risk register. This risk may arise from cost, missing a milestone, delivery method, etc. These risks can be managed as guided by the risk management plan. Procurement-related requirements, both technical ones that the seller is required to meet and contractual ones, become part of the requirement documentation. These requirements are managed as guided by the requirement management plan. Analyses of seller's data. The work performance data contains raw performance data from the seller's side, such as activities in progress and those finished, costs incurred, and so forth. As described in Chapter 13, by using earned value analysis you will compute the performance indexes and variances for both schedule and cost. Comparing these with the agreed-upon target, e.g., SOW, will measure the deviation. Also, as explained in this chapter, you can perform trend analysis to predict the estimate for cost at completion so as to monitor cost, e.g., is it on track, improving, or getting worse? You can also keep track of procurement by conducting performance reviews, as discussed in this chapter in the control quality section. As in any control process, from the seller data you will measure certain quantities about schedule, resource, and cost performance and compare them with their expected values, which are found in the contract or agreement or agreed-upon procurement documents.